Hello. In this video, we will prove the Pythagoras theorem. We will prove it using the area-based method. So what is the Pythagoras theorem? The theorem simply states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. So, if we are given a right-angled triangle A, B, C, then the Pythagoras theorem states that the hypotenuse, which is AC, square is equal to the sum of the squares of the other two sides. So, AB square plus BC square. In other words, if the length of AB is A and the length of BC is B and the length of the hypotenuse AC is C, then C square is equal to A square plus B square. So how do you prove that in a right-angled triangle, C square, the hypotenuse, square is equal to A square plus B square? Note that the area of a square with side S is given by S multiplied by S, which is S square. So this is what the new diagram will look when we have placed the three squares on the corresponding sides of the right-angled triangle. Let us now label the diagram. And this is how our diagram looks with the labels on. Okay, so we have the right-angled triangle, ABC, and then we have the square APQC that sits on the hypotenuse. We have the square ARSB that sits on this side of the right-angled triangle, AB, and we have the square BMNC that sits on BC, the third side of the right-angled triangle. So with some colors on, the diagram now becomes a little better to understand. So we have the original right-angled triangle, ABC. Let's assume the hypotenuse is length C, AB is length A, and BC is length B. Because APQC is a square, all sides are of equal length, and because AC is C, QC is also C, and so is PQ and AP. Similarly, the yellow square ARSB is a square with side A each, and the yellow square BCMN is a square of side length B each. And so the area of the red square becomes C multiplied by C, which is C square. The area of the left yellow square is A square, and the area of the right yellow square is B square. Because the Pythagoras theorem, which we have to prove, states that A square plus B square is equal to C square in the blue right-angled triangle, it would be the same as proving that the sum of the areas of the two yellow squares would be equal to the area of the red square. In the next diagram, we have drawn three lines. So we have connected R with C, we have connected B with P, and we have drawn a perpendicular from B onto AC and PQ. So this is 90 degrees and this is 90 degrees. Because APCQ is a square, so all angles are right angles. So angle PAC is also 90 degrees and angle APQ is also 90 degrees. So that makes APFE a rectangle. Now we know ARSB is also a square. So all its angles are right angles. So angle ABS is 90 degrees. And we know triangle ABC is a right angled triangle. So angle ABC is 90 degrees. So angle SBC is 180 degrees. And therefore angle SBC is equal to 180 degrees. And so SBC becomes a straight line. Now because ARSB is a square, so the opposite sides are parallel to each other. So AR is parallel to SB, but we know SBC is a straight line. So AR is parallel to SB and also parallel to SBC. Now because PAEF is a rectangle, we know the opposite sides of the rectangle are also parallel to each other. And so AP is parallel to EF. But we know BEF is a straight line. So AP is also parallel to BEF. Okay? In the original triangle ABC, the right angled triangle, let angle BAC, this angle, be X. Now we know angle RAB is 90 degrees because it is part of the square RABS. And we also know angle PAC is also 90 degrees because it's part of the square PACQ. Therefore, in the orange triangle RAC, angle RAC is equal to 90 plus X degrees. Right? Similarly, in the yellow triangle or yellow-green triangle, PAB, angle PAB is equal to 90 plus X degrees. So now focusing on the two colored triangles, we have determined that RAC, angle RAC, is equal to angle PAB. Also, side RA is equal to side AB because they are sides of the same square, and side AP is equal to side AC. Again, they are sides of the same square, which means that the two colored triangles are congruent to each other. That is, triangle RAC is congruent to triangle PAB. This is according to the SAS congruency theorem, which states that if two sides and the included angle of one triangle are equal to the two sides and the included angle of another triangle, then the triangles are congruent. This means that the areas of the two triangles that are congruent are equal. So the area of triangle RAC is equal to the area of triangle PAB. So areas of the two triangles, triangle RAC is equal to the area of triangle PAB. Next, I want you to focus on triangle RAC and square RABS. we see that they are both between the same parallel lines and they are on the same base RA, right? So that means the area of the triangle RAC is equal to half the area of the square RABS, because we know that the area of a triangle is always half the area of a parallelogram if both are on the same base and between the same parallels. Similarly, when we look at the triangle PAB and the rectangle PAEF, we find that both of them are between the same parallel lines AP and BEF, and they are both on the same base AP, right? So once again, in this case, triangle PAB's area would be equal to half the area of the of the rectangle PAEF. So what have we done so far here? So we have proved that the area of these two colored triangles are the same because both the triangles are congruent to each other. We have also proved that the area of this triangle, the colored triangle, is half the area of this colored square. And likewise, we have also proved that the area of this colored triangle is half the area of the colored rectangle. So if we were to combine the three results, we can say that the area of the yellow square is equal to the area of the red rectangle. In the same way, we can prove that the area of the yellow square BC and M is equal to the area of the red rectangle FQCE. If we combine these two results, we find AC square is equal to AB square plus BC square. Proved. Hope you enjoyed today's video. Thanks for watching.